In this video, we're going to see how we can calculate the expected outcome of a discrete random variable. Now remember, the expected outcome, E of y, is the population average of the random variable y. So that means that if we were to repeatedly sample from the population, then the expected value would be the average of the outcomes we observe if we sample an infinite number of times. Now, in this case, y represents a financial investment, and there are four possible outcomes of this financial investment. You could make a profit of £100, you could make a profit of £0, you could make a loss of £50, or you could make a loss of £1,000, and the probability of each of those, the probability of making a profit of £100 is 0.5, so 50% of the time you'd make a profit of £100. With probability 0.1, you make zero profit, so that's 10% of the time you'd make zero profit. With probability 0.38, you make a loss of £50, so 38% of the time you make a loss of £50, and with probability 0.02, you make a loss of £1,000. That is 2% of the time you'd make a loss of £1,000. Now, the expected value of a discrete random variable is just equal to the sum over all possible outcomes of y of the probability of each possible outcome multiplied by the corresponding outcome. That is, we're essentially weighting each of these outcomes, 100, 0, minus 50, and minus 1000, by the likelihood of that outcome occurring. So 50% of the time we'd get an outcome of 100, so we'd weight that by 0.5. So the expected value here is just going to be equal to the probability that y is equal to 100 times by 100 plus the probability that y is equal to 0 times by 0 plus the probability that y is equal to minus 50 times by minus 50 plus the probability that y is equal to minus 1000 times by minus 1000. Now, if we substitute in our probabilities here, the probability that y is equal to 100 is 0.5, and we'll multiply that by 100. The probability that y is equal to 0, well, that's equal to 0.1, and we'll multiply that by 0. The probability that y is equal to minus 50 is equal to 0.38. We'll multiply that by minus 50. And the probability that y is equal to minus 1000 is 0.02, and we'll multiply that by minus 1000. If we multiply out each of the terms, we get this is equal to 50 plus 0 plus minus 19 plus minus 20. And this is going to be equal to 11, or £11. So what this is telling us is that on average, if we invested in this investment a very large number of times, we would expect to make a profit of £11. That's not saying that every time we make a profit of £11. Sometimes we'll make a profit of £100, sometimes we'll make a loss of £50, sometimes we'll make a loss of £1,000, but on average, we'll make a profit of £11. Now, let's suppose that we didn't just buy 1 unit of investment of y. Let's suppose that we bought 3 units of investment. So what that would do is, in effect, it would mean that if the investment yields a profit of £100, we'd get 3 lots of that, we would make a profit of £300. Similarly, if the investment makes a loss of £1,000, we'd make a loss of 3 times that, we'd make a loss of £3,000. So, how do we calculate the expected outcome? Well, essentially, we're generating a new variable z, which is equal to 3 times the outcome of y. because whenever y makes a profit of £100, the profit that we make from 3 shares is going to be equal to £300, and so on. Now, if we want to find the expectation of any constant times by a random variable, this is just the same as that constant times by the expectation of the original random variable y. So in this case, our new outcome z is just equal to 3, which is a constant, times by the original random variable y. So we can write that the expectation of z is just equal to the expectation of 3 lots of y, and we can take that 3 outside of the expectation, giving us that this is equal to 3 lots of the expectation of y. Now, we already know that the expectation of y is equal to 11, so we can write that the expectation of z, which is the profit that we make from investing 3 times in this investment, is going to be 3 times by the expectation of y, which is 3 times by 11, which is equal to £33. So our expected profit is equal to £33. Now, you might say to yourself, hang on, I don't believe this rule. Can we verify this with an example? Well, let's try and illustrate this using this very same example. Now, if we have a random variable z, which is based on 3 times y, that means that the outcome of z is always going to be equal to 3 times the outcome of y. So when y is equal to 100, z would be equal to 300. When y is equal to 0, z would be equal to 0. When y is equal to minus 50, z is going to be equal to 3 times by minus 50, or minus 150. And when y is equal to minus 1000, z is going to be equal to minus 3000. Now, the probabilities of each of these outcomes are just going to be the same as the corresponding probabilities relating to y. So, for instance, whenever y is equal to 100, that follows that z is equal to 300. So the probability that z is equal to 300 is just equal to the probability that y is equal to 100, which is equal to 0.5. And we can fill in all of the probabilities just by looking at the corresponding probabilities relating to y. Now, just as we did for y, we can calculate the expectation, or the population average, of z by finding the sum of the products of the probabilities multiplied by the relevant outcomes. So, substituting in our numbers, we're going to look at the probability that z is equal to 300 times by 300 plus the probability that z is equal to 0 times by 0 plus the probability that z is equal to minus 150 times by minus 150 plus the probability that z is equal to minus 3000 times by minus 3000, which gives us 0.5, that's the probability that z is equal to 300, times by 300, plus 0.1, that's the probability that z is equal to 0, times by 0, plus 0.38, that's the probability that z is equal to minus 150, times by minus 150, plus 0.02 times by minus 3000. Putting all this into a calculator gives us that the expected value of z is equal to £33. And that's exactly the same answer that we got above. In this video, what we've seen is that if we have a random variable y, let's say, and we multiply it by some constant a, if we want to find the expectation of this new random variable, what we can do is we can effectively take that constant multiplier outside of the expectation, and we can write that the expectation of this new variable ay is just equal to the constant a times by the expectation of y. Now, this is just one rule relating to a linear combination of random variables. And more generally, if you have the expectation of a sum of random variables, then the expectation of this sum is just the same as the sum of the expectations. We've also got that the expectation of a linear combination of random variables, so some constant a times by a random variable x plus some constant b times by a random variable y, this is going to be equal to a times by the expectation of x plus b times by the expectation of y. Now, one thing to be really careful of is that if you have two random variables multiplied together, in general, it will not be the case that the expectation of xy is equal to the product of the expectations. So in general, the expectation of a random variable x multiplied by the random variable y will not equal to the expectation of x times by the expectation of y. There is one case that contradicts this, and that is when the random variables x and y are what are known as independent random variables.